You have been lied to. You have been told a story about light that sounds profound, but is actually just a cover-up for a failure of language. You have been told that light is a shapeshifter, that it is both a particle and a wave, that it is a Wavicle. This is nonsense. It is a comforting bedtime story told to physics students to stop them from asking the terrifying questions. Light is not a particle. Light is not a wave. Light is not both. And it is certainly not switching between the two like an indecisive ghost. If you want to understand the architecture of the universe, you have to burn the picture in your textbooks. You have to stop imagining little billiard balls bouncing off mirrors. You have to stop imagining water ripples moving through empty space. Those are metaphors, and they are broken. The reality is something else entirely. Something stranger. Something that refuses to fit into the boxes your primate brain evolved to understand. Let's go back to the scene of the crime. The year is 1704. Isaac Newton is sitting in a darkened room in Cambridge. There is a single beam of sunlight cutting through the dust, hitting a prism. He sees straight lines. He sees sharp shadows. He sees geometry. To Newton, the conclusion is obvious. Light is bullets, little corpuscles of pure speed shooting from the sun, hitting your retina like microscopic hail. Makes perfect sense. Waves bend around corners, bullets do not. Light travels straight. Therefore, light is a bullet. But nature has a way of humiliating geniuses. Fast forward 100 years to Thomas Young. He takes a card, cuts 2 razor-thin slits in it, and shines a light through. If Newton was right, if light is bullets, you should see 2 bright lines on the wall behind the card. 2 slits, 2 piles of bullets. Simple. But Young doesn't see 2 lines. He sees a barcode. He sees a series of bright and dark bands spreading out across the wall. Interference. Stand on the edge of a pond and throw 2 rocks in at the same time. Watch the ripples. Where the peak of one wave hits the peak of another, the water jumps up. Where a peak hits a trough, the water goes flat. They cancel out. This is exactly what Young saw on his wall. Light plus light equal darkness. Particles cannot do this. Bullets do not cancel each other out to create silence. Only waves do this. So the verdict was in. Newton was wrong. Light is a ripple in the electromagnetic field, a wave washing over the universe. For a century, we thought we had it solved. James Clerk Maxwell wrote down the equations of electromagnetism, and they were beautiful. They described light as a self-propagating dance of electric and magnetic fields. It was elegant. It was smooth. It was continuous. We thought we could pack up and go home. We thought the universe was a machine made of waves and matter, ticking along perfectly. But we were arrogant, and the universe was about to break our legs. It started with heat, the ultraviolet catastrophe. It sounds like a bad sci-fi movie, but it was a mathematical nightmare that threatened to destroy physics. Here is the problem. If you heat up an iron bar, it glows. Red, then yellow, then white. According to the wave theory of light, a hot object should emit infinite amounts of energy at short wavelengths. If you opened your oven, the ultraviolet radiation should blast you into dust instantly. The math said, reality shouldn't exist. But you can open your oven. You don't die. The wave theory was lying. Enter Max Planck. He was a conservative physicist. He didn't want to start a revolution. He just wanted the math to work. So he did something desperate. He guessed. He said, what if energy isn't continuous? What if light doesn't flow like water, but comes in chunks? He called them quanta. He thought it was just a mathematical trick, a bookkeeping hack to fix the equations. He didn't think it was real. But then Albert Einstein looked at a piece of metal and realized Planck had accidentally discovered the fundamental graininess of reality. Einstein looked at the photoelectric effect. Shine a light on a metal plate, and electrons pop off. If light is a wave, simply turning up the brightness should knock off more electrons with more speed. Think of it like a tsunami hitting a seawall. A bigger wave hits harder. But that's not what happened. You could shine a blindingly bright red light on the metal, and nothing would move. The electrons sat there, bored. But shine a dim, weak beam of blue light, and snap. Electrons flew off instantly. The intensity didn't matter. Only the color mattered. Only the frequency mattered. Einstein realized the terrifying truth. Light isn't a tsunami. Light is a hail of stones. A red light is a landslide of pebbles. They hit the wall, but they are too light to knock anything loose. A blue light is a sniper rifle firing heavy bullets. Even one single bullet can knock an electron free. Einstein won the Nobel Prize for this. He proved that light kicks like a particle. It hits like a distinct, localized lump of energy. He called it the photon. So here we are, trapped in a paradox that makes no sense. You do the double slit experiment, and light behaves exactly like a smooth, spreading wave. You do the photoelectric experiment, and light behaves exactly like a hard little rock. It creates interference like a wave, but it hits the detector like a particle. And this is where the textbooks give up. They shrug and say, it's wave-particle duality. They tell you, sometimes it's one, sometimes it's the other. It depends on how you look at it. This is the lie. This is the moment we stop pretending. Light is not switching back and forth. It is not confused. It is not waiting for you to look at it so it can decide what outfit to wear. Wave and particle are not properties of light. They are properties of us. They are clumsy words we invented to describe rocks and water. We are trying to describe a four-dimensional quantum object using the vocabulary of a caveman who only knows about stones and ponds. The failure is not in the light. The failure is in our language. Light is a quantum object, and a quantum object is a third thing. It is something that has no analogy in the macroscopic world. There is nothing in your house, nothing in your life, nothing in your dreams that behaves like a quantum object. So how do we understand it? We have to stop looking for analogies and start looking at the architecture. We have to look at the probability amplitude. This is the Feynman bridge. Richard Feynman, the man who could explain the universe to a bartender, stopped trying to use the old words. He stopped saying wave and particle. He said, imagine a clock, a tiny, invisible stopwatch attached to every single photon in the universe. This stopwatch doesn't measure time. It measures a thing called phase. As a photon moves from a lamp to your eye, the hand on this stopwatch spins. Round and round and round. Millions of times per inch. Now, here is the magic. Here is the rule that runs the cosmos. To find out where the light goes, you don't draw a straight line. You have to consider every possible path the light could take. The path straight to your eye. The path bouncing off the mirror. The path bouncing off the moon. The path going to the Andromeda galaxy and coming back. Light takes all of them, simultaneously. And for each path, the little stopwatch spins a different amount. When the light arrives, you look at all those stopwatches. You add up the arrows. If one arrow points up and another points down, they cancel out. Darkness. If they both point up, they add together. Brightness. This isn't a wave splashing. This isn't a particle bouncing. This is the sum over histories. Light is a bundle of possibilities exploring the entire universe at once. The wave pattern you see? That is just the map of where the stopwatches add up. The particle click you hear? That is just the moment the universe demands a decision. The photon is not a thing that travels through space. The photon is a calculation that the universe performs to determine where energy is allowed to land. It is a ghost of probability that only becomes real when it hits the wall. But we need to go deeper. Because if light is just a probability game, what happens when you watch it? What happens when you force the universe to show its hand? This is where reality gets truly weird. This is where we have to talk about the eraser. The quantum eraser is the experiment that destroys the concept of time. Imagine the double slit experiment again. Light goes through two slits, creates an interference pattern. Now, imagine we tag the light. We put a special filter on the slits, so we know which slit the photon went through. We measure the path. The moment we know the path, the interference pattern vanishes. The universe stops behaving like a wave and starts behaving like particles. Two bright clumps. This is the standard story. Observation collapses the wave function. But the quantum eraser does something illegal. It measures the path, but then scrambles the information after the photon has passed the slits, but before we look at the data. We erase the knowledge of which path it took. What happens? The interference pattern comes back. Read that again. The pattern comes back. It's as if the photon knew we were going to erase the information in the future and decided to behave like a wave in the past. It suggests that reality is not about physical interactions. It is about information. If the information exists in the universe to tell us which path the photon took, it behaves like a particle. If that information is destroyed, it behaves like a wave. The photon doesn't care about time. It cares about knowledge. This implies that the universe is not made of hard matter. It is made of information processing. We are living inside a computation. Now let's look at the speed of light. You think you know what c is. 29,792, 458 meters per second, the speed limit of the cosmos. But from the perspective of the photon, that speed means something entirely different. It means the end of time. Einstein's special relativity tells us that the faster you move, the slower time passes for you. If you reach the speed of light, time stops completely. This is not a metaphor. For a photon emitted by a star in the Andromeda galaxy, traveling for 2.5 million years to reach your eye, zero time has passed. From the photon's perspective, it was born on the star and died on your retina in the exact same instant. It didn't travel. It didn't experience distance. For light, the universe has no size and no time. It exists everywhere along its path simultaneously. So, when we say light travels, we are imposing our slow, heavy, time-bound existence onto an entity that transcends time. Light stitches the universe together because, for light, the universe is already stitched. It is a single point of interaction. And what about the darkness? What about the empty space? You think space is empty because it's dark, but darkness is just a lack of photons that your eyes can see. In reality, the vacuum is boiling with light that you cannot see. We call them virtual photons. This is the secret mechanism of the universe. Hold two magnets close to each other. You feel them repel. How? How does one magnet know the other one is there? They aren't touching. They are exchanging virtual photons. The electromagnetic force is literally a game of catch played with invisible light. Every atom in your body is held together by this exchange. The reason you don't fall through the floor is because the electrons in your feet and the electrons in the floor are screaming at each other using a language made of light. Light is not just what you see. Light is the architectural glue of reality. Without this invisible exchange of virtual particles, matter would dissolve into a fine mist. Let's push this to the breaking point. Let's talk about interaction-free measurement. This is the Elitzur-Weidman bomb tester problem. Imagine you have a bomb so sensitive that if a single photon hits it, it explodes. But you also have a pile of duds that look exactly like the bomb, but don't explode. You want to find a working bomb without blowing it up. Classically, this is impossible. To check if it works, you have to touch it. To touch it is to trigger it. But using the quantum nature of light, you can do the impossible. You can set up an interferometer where the light has a choice of two paths. One path goes through the bomb, the other doesn't. If the bomb is a dud, transparent, the light waves from both paths interfere and exit one way. If the bomb is real, opaque, it blocks one path. This destroys the interference. The light from the safe path now has a chance to exit a different way. If you detect a photon at that specific exit, you know the bomb is real, and you know the bomb is live. But the photon never touched the bomb. If it had touched the bomb, it would have exploded. The photon took the safe path, but the possibility that the bomb was on the other path changed the behavior of the photon. The what if changed the reality. This proves that light explores paths it doesn't take. It probes the universe with ghost fingers. It can see things without looking at them. It proves that the universe is aware of things that could happen, not just things that do happen. And this leads us to the ultimate realization. We call it light, but that's just a word for a visible slice of a monster. Light is the electromagnetic field. This field is everywhere. It is inside your atoms. It is in the empty space between stars. It is inside your brain. The field is like a vast, calm ocean filling the universe. A photon is not a separate object floating in the ocean. A photon is a wave in the ocean, a splash, an excitation. When you see a star, you aren't seeing a bullet that traveled across space. You are seeing a ripple in the field that was triggered by an electron on the star, traveled for 1 billion years, and then slapped an electron in your eye. The field is the only thing that is real. The particles are just the temporary songs the field sings. This applies to you, too. You think you are made of particles, electrons and protons? Wrong. The electron is not a particle either. The electron is a ripple in the electron field. The quark is a ripple in the quark field. You are not a collection of solid objects. You are a complicated knot of vibrating fields, trapped in a stable loop. You are a standing wave. The only difference between you and the light coming from your lamp is the frequency of the vibration and the rules of the field. You are made of the same fundamental stuff. So, why does this matter? Why should you care about probability amplitudes and quantum fields? Because it changes what you are. If light can be a wave or a particle depending on how we question it, then reality is not fixed. Reality is a dialogue. It is a handshake between the observer and the observed. We used to think the universe was a clockwork mechanism that ticked along whether we were here or not. Quantum mechanics says no. It says the universe is a cloud of probability that only snaps into focus when it needs to interact. We are not just watching the show. We are directing the camera. When you look in the mirror, you are seeing a quantum interaction. Light hits your face, excites the field, ripples to the mirror, bounces, ripples to your eye, and collapses into a chemical signal. That entire chain relies on the fact that light is neither a wave nor a particle, but a probabilistic ghost exploring every possible geometric path between you and the glass. You are looking at yourself through the lens of the multiverse. Every reflection is a sum of infinite histories. So, the next time someone tells you, light is both a wave and a particle, correct them. Tell them that is a lie for children. Tell them light is a feature of the quantum field. Tell them it is a probability distribution with a spin of 1. Tell them it is the universe deciding where to put energy based on the information available. And then tell them that they are made of the same ghosts. We are not matter. We are music. We are the vibrations of the fields. And the silence between the notes is just as important as the sound. That is the truth about light. It illuminates the world not by touching it, but by exploring the possibilities of what the world could be. And that is far more beautiful than a bullet or a ripple. That is the magic of the real. Comment. Question. If reality is based on information, and erasing information changes the past, do we have free will? Or are we just processing the data of the universe? Let the crisis begin in the comments.